Good morning, everyone. My name is Vanshi Krishna. My teammate name is Lakshman Rohit. Our topic is information retrieval in healthcare. Today, we will explore how information retrieval supports clinical decision making, improves healthcare efficiency, and connects AI with patient care. Coming to the next slide, introduction to information retrieval. Information retrieval refers to the process of searching, retrieving, and ranking relevant data from large collections. In healthcare, these data sources include medical records, lab results, radiology, images, and millions of published studies. The main goal of IR is to give healthcare professionals quick access to accurate, evidence based information so they can make better clinical decisions. For example, when a doctor types in symptoms or a diagnosis, the IR system instantly pulls guidelines, treatment options, and patient histories from multiple databases. And the next slide is about importance of information retrieval in healthcare. Today, the modern hospitals handle enormous data volumes, from HRS to genomic reports. Manually, searching this information is time consuming and error prone. These information retrieval systems automate the process, allowing clinic, clinics to locate the most relevant patient or research data in seconds. By this reduces diagnostic delays, improves the treatment precision, and also even supports public health monitoring by detecting patterns such as outbreaks or rare disease clusters. The next slide is about what is a clinical decision support system. A clinical decision support system, or CDSS, is an intelligent software system that uses information retrieval and artificial intelligence to help healthcare professionals make evidence-based decisions. It can also recommend drug dosages, warn about allergies, and also interpret lab results and summarize the patient histories. In short, clinical receipt support system bridges the gap between medical data and actionable client insight. The next slide is components of a clinical disease support system. A typical CDSS has four key components. They are knowledge base, inference engine, user interface, information retrieval layer. And the first one is knowledge base. It is a repository of medical guidelines, clinical pathways, and pharmacological rules. And the next one is inference engine. It applies logic or machine learning algorithms to interpret the data and generate suggestions. And the third one is user interface. It presents, recommends clearly to the clinician and also displays results and insights clearly. And the fourth one is information retrieval layer. The information retrieval layer is crucial because it extracts relevant data from electronic health records and medical literature for analysis. Together, these layers ensure that every suggestion is data driven and verifiable. Let's walk through the how information retrieval actually works inside a CES. It has the components data collection, indexing, query processing, retrieval and ranking, and the final is decision output. First one is data collection. It pulls the data from EHRS, imaging, and medical databases. And the next one is indexing. It converts unstructured text into searchable formats using standard terminologies like SNOMED or UMLS. The third one is query processing. It uses the natural language processing to understand the doctor's input. And the fourth is retrieval and ranking. It searches the indexed data and ranks it by its relevance. And the final one is decision output. It displays recommendations with supporting evidence. and also presenting evidence-based guidance. This pipeline ensures every query returns the most meaningful medical information. Coming to the example, information retrieval in action. Consider a clinician asking, what is the optimal treatment for diabetic patients with hypertension? The information system searches recent research articles and filter out medications and retrieves the evidence-based treatment plans. It then ranks them by reliability and recency. So the doctor sees the safest and most updated recommendations. This real-time capability can directly influence patient outcomes.
Hello everyone, this is Lakshman Rohit. Now coming slides explained by me. Now coming to the tools and framework in healthcare. Several cutting-edge tools make in IR healthcare possible. IBM Watson Health uses the deep NLP to analyze clinical text and suggest treatments. Elasticsearch enables rapid indexing and search across massive datasets. OpenEHR FHIR provides standards for in- interoperable healthcare data sharing. BioASQ, a biomedical questioning answering platform designed for research retrieval. These frameworks allow integration of structured and unstructured data across different hospital systems. Then benefits of IR in CDSS. IR brings multiple benefits. It reduces diagnostic errors by giving clinical the full context before making a decision. It provides real-time access to the latest medical knowledge. It enhances workflow efficiency, freeing doctors from repetitive data search. It supports personalized medicine where treatment is tailored to each patient history. Finally, it enables predictive analytic forecasting potential complications before they occur. Yeah, we can also see patient-centric advantages. From the patient perspective, IR improves safety and trust. It ensures that treatment decisions are grounded in verified evidence. By minimizing side effects or conflicting prescriptions, patients receive faster, more accurate diagnosis, and also the healthcare teams gain the ability to track and monitor outcomes efficiently, accurately. Yeah. Now, deeply we look at into the challenges in IR for healthcare. Despite its promises, IR in healthcare faces serious challenges. Data variety. Medical data comes in multiple formats, notes, images, voice, structure codes, making integration complex. We also have the privacy. System must comply with HIPAA and ensure encryption, de-identification, and secure storage. Terminology ambiguity. The same term may have different meaning across contexts. For example, lead has metal or an ECG lead. Trust in AI. Clinicians must trust that automated recommendations are accurate and unbiased. We also see the data integration issues. Most healthcare institutes maintain solid systems, labs, radiology, pharmacy that don't communicate well. IR relies on merging this into a unfined searchable index. By achieving seamless integration requires awareness to interoperability standards like FHIR and HLS7, plus strong data governance policy. Then privacy and security. Maintaining patient confidently is prominent. IR system must use anonymization, access controls, and audit trails. Moreover, with the rise of cloud-based healthcare solutions, encryption during data transmission and storage is essential. Without these safeguards, no IR system can gain regulatory or public trust. Yeah, coming to the role of AI and deep learning, artificial intelligence takes IR to the next level. Models such as BioBird and Clinical Bird understand complex biomedical language, enabling contextual search beyond keywords matching. AI can read through thousands of papers, understand relationships between symptoms, genes, and drugs, and thus summarize them into recommendations. This is transforming evidence-based medicine. Now, explaining the explainable AI and transparency. One critical demand in healthcare is explainable AI. Clinical clinicians need to know why the system recommended a particular drug or diagnosis. Explainable IR models present reasoning steps or highlighting key evidence sentence prompting accountability and ethical AI adoption. And also integration with IoT variables. The future of IR will integrate data from wearable devices, heart rate monitors, glucose sensor, and smartwatches. Real-time health streams will feed into IR system that retrieves preservative insight or trigger alert when anomalies occur. This moves healthcare from reactive to proactive care. Now, predictive analytics and early diagnosis. With continuous data and strong retrieval models, we can move towards predictive analytics. IR can support models that predictive device onset, hospital readmission, or treatment failures, allowing earlier intervention. This predictive layer will redefine clinical workflow in the next decades. Also, research and academic application beyond hospitals. IR is invaluable for medical research. Systems like PubMed, Semantic Scholars uses IR to help scientists to find relevant literature. Advanced retrieval models can even now future trends and opportunities. Future research in IR for healthcare will focus on hybrid IR AI pipeline that combines symbolic reasoning with neural networks, multilingual retrieval, slow global medical research become accessible to all regions. Then also we have the continuous learning system that update a new evidence is published automatically. User adaptive interface that personalize the way information is displayed to each cli- clinician. I think we all covered all the topics relevant to the presentation. Now coming to the conclusion. Yeah, to conclude, information retrieval from the foundation of intelligent healthcare system. It empowers professionals with fast, accurate, evidence-based insight. As the data continues to grow, IR ensures that knowledge remains accessible, transparent, and actionable. Yeah, I think we have covered this. Thank you for your attention. Thank you everyone for listening, and also thank you for giving this opportunity.